So here's my IDTB. Notice that I actually connected the switches to my breadboard first in proper order also as it was terminated in the IDTB. So I just can just easily pull them out in order also and connect them to the ICs here. Okay, so I have prepared already the ICs, the 7432, 7400 and 7408. And notice that I have also connected already the power supplies of all the three ICs, no? So that's the positive on the 14th and on the 7th pin also, so connected in cascade to the other ICs also. So this is taken from actually from my output, no, external power supply already taken from the 7805. So this means all the power supplies coming into my TTL circuits now, or TTL ICs, are actually 5 volts already. Never use a power supply before the 7805 because you might be using 12 volts here as input, so it will burn out your TTL ICs, which the standard power supply is only 5 volts. Okay, so again, no, pin 14 is the positive supply, while pin 7 is the negative power supply, no, this one blue. So it is connected also to the other ICs. Now I will be connecting S1, switch 1 to pin 13 of 7408, and S2 to pin 12 of the same IC, no, IC1. So here it is, no. So this is switch 1 here, the red one, connected to pin 13. So let me see. So this one, and then S2 on the second pin from my switch, connected to pin 12 of 7408. Okay, can you see this? Okay, so now there. Now after that, if you can see the schematic, no, these are just connected also to pin 1 and pin 4, which is tied down to the inputs of each NAND gate. Okay, so now I will connect pin 1 and 2, no, we will tie this down, and pin 4 and 5 of the same IC, that's the 7400. Okay, so this is my 7400. So pin 1 and 2 first. So this is pin 1 connected, tied down to pin 2, no? And then pin 4 also. So pin 4, this is pin number 4, that's 3, vacant ang 3, and then pin 5 of the same IC. So tied down na sila, class. Okay, so notice also that the tie down pins, no, 1 and 2 and 4 and 5, these are connected to the same input terminals, no, S1 and S2. So we will now put a jumper wire from this portion to that portion, and so with this one. Okay, so from these tie down pins we will connect to S2, no, S2 is actual, S1, sorry. So that is pin 13 here, connected to pin 13. And then pins 4 and 5, no, is also connected to S2, which is pin 12, no, dari po siya. Okay, so now we're done with the inputs. Okay, so since we're done already with our inputs, we will now start connecting this one first, no? So we will connect, okay, we will connect, or we will tie down pin 12 and 13 first, and then connect it to pin 11 of IC1. So take note that this is the 7400, the NAND gate. Okay, so this is the 7400, the center. So where's my pin 12 and 13? There is above. So pin 12 and 13 tied down. So and then from these tie down pins 12 and 13, we will connect this to IC1 pin 11. So connect, and where's pin 11 here, no? So this is 8, 9, 10, 11. So the output na ni siya of the output of 7408 pin 11. Okay, so now we will connect LED 1, no, to pin 11 of 7400. So actually this is my LED 1, no, the orange. So it's actually terminated here in order also the outputs, no, if you look at this here. So here's the orange one. So this is now our LED 1. So I will pull this out and connect this to pin 11 of the 7400. Okay, so let me see. Okay, so there it is. Next is we will connect the outputs of the 7400 or NAND gates, no, to the inputs of the 7432, which is an OR gate. So, and this one also, pin 6 of the 7400 to pin 2 of 7432. Now this is my 7432 here, huh? This one. So I will find pin 3 of the 7400. So it's here, it is, no? It's quite crowded already. So this is pin 3, the 7400, and then connected to pin 1 of the 7432. Here it is, it's still vacant, huh? Okay, and pin 6 of the 7400. So here it is, still vacant. Okay, to pin 2 of 7432. So okay, so done. Now next is just we will connect the output of the OR gate here, pin 3, to LED 1 or LED 2, sorry, no. So here's my LED 2. It's actually yellow, so I will just pull this out and connect this to pin 3. Okay, so I think we're done now with this schematic diagram. So next is we will try to check the outputs basing from the inputs now. Okay. Okay, so going back to the circuit of this experiment. So you might be asking, why are we using a tied down inputs of a NAND gate? So actually this is also to verify the discussions we have earlier, that we can use actually a NAND gate instead of a direct 74004 or an inverter, no? So at the same time we are verifying if this configuration is working also as inverter. Okay, so this one, this IC2 IC is actually a NAND gate, but you can replace this with a 7404. So that's an inverter, directly as an inverter. Okay, so having connected all the components in our breadboard, basing from our schematic diagram here, so we will now perform the exercise, basing also from the procedures. So number one, do not connect any power to the system and set all data or the IP switches to on, so up position. So zero logic, actually it means zero logic, because note that our DIP switches are active low. That is, if it is turned on, it is zero logic. If it is turned off, it means one logic. So I will now turn on the DIP switches. That means this is now a zero logic. All the inputs are now zero, and turn on the power supply. So there it is. So our power supply is now turned on. Our switches are actually in zero logic, and look at the LEDs, no? LED 1 and LED 2 are actually lit, no? So that means the logic here in our inputs is 0 0. So now we will perform 0 1. So I will now turn off S2 and see what happens. Okay, so nothing. Now 1 0. So I will now 1 0. Okay, that's the next. So I will now turn this off to have a logic of 1, and turn this on to have a logic of 0, and see what happens. It is both LEDs are still lit up. So next, the last is 1 1. So all the switches will be down to have a logic of 1, and see what happens. Both LEDs are now turned off. So notice if there is a difference between the outputs of LED 1 and LED 2.